Alright, guys, in this class, we'll be um, expanding cos to the power of 3 theta and sine to the power of 3 theta using the De Moivre's theorem. So, to do this one, you really need to know the fundamental formula, the real formula that you need to apply. So, I'm going to run through how to derive this formula and as well how to solve sine raised to power 3 cos theta. So now you know the basis of our expansion is all directed to De Moivre's theorem, and De Moivre's theorem is Z is equals to R cos theta plus I sine theta, right? And we say that if we now peradventure have Z raised to power n, we will now have this. Okay, we have established this one plus I sine theta raised to power n will definitely become R raised to power n cos n theta plus I sine n theta. We said this one countless times in this series. Okay, so what we want to note here is this one to the extension of this one first. So we should note that Z raised to power n is definitely equal to writing this into n theta plus I sine n theta. Should have this at the back of our mind as our first notation. Now, on the other hand, if I should have Z to the power of minus n, right, like an inverse of this De Moivre's theorem, could you believe that this will also be written as R raised to power minus n, okay, into the cos of minus n, right, theta, then plus sine minus n, then theta, right? Now for cos, and this one is in between the range, the what is it called? Is in between the range of the radian 0 to 90 degrees. So definitely cos will be positive regardless of the sign of that angle. So this is also the same thing as writing R raised to power minus n into the cos of n theta, then a negative of sine in the first quadrant of the cardinal point will be negative. So in that case, I'll just write a negative I, the sine of n. Okay, so the second thing we want to work with is when z is raised to power minus n, we will have r minus n, okay, into the cos of n theta minus I sine n theta. So we want to, this will be our second notation. Okay, so that is for this one. Now let's assume that we want to add these two together. Let's add both this first one and this second one. Let's do the addition quickly. We want to do the addition of the De Moivre's theorem and the inverse. So I would have, if I have z to the power of n plus z to the power of minus n, I want to add this together. Okay, so I'll be having r raised to power n, that means this part here first, raised to power n to the cos n theta plus I sine theta, okay, sine n theta plus r to the power of this, then I'll have cos, still cos n theta, but this time around minus I sine n theta. Okay, now for this one, this is the addition. So we are trying to prove the general formula we're going to be using for this question. So let's r be equals to 1. We say r is equals to 1. That means this r here, 1 raised to power anything will still be 1, right? So this r here raised to power as power 1 raised to power anything will still be 1. So therefore I'll be having my z raised to power n, right, plus, I can still write that z raised to power minus n as this, okay, is equal to, since it's now 1, I will just have the cos n theta, okay, plus sine n theta. Alright, now I have plus cos n theta minus I sine n theta. So since I have this already, this implies that this can cancel out this, isn't it? So it's the same as writing, don't forget that I have my n here, so it's the same as writing z power of n plus 1 over z to the power of n, okay, will be equal to 2 cos n theta. Alright, now I haven't gotten this. Let our n be 1. Let's assume we are doing it in the first power, so let n be equals to 1. Therefore I will have z plus 1 over z, since our n is 1, will be equal to 2 cos theta. Okay, so we have gotten this. To get this in the nth power will now be, if you recall from the De Morph's theorem from the beginning, this let me just state it here. Z raised to power n is the same thing as bringing the n on this the n here plus I sine theta. The n on top of this one, we now brought it down, so that means, okay, let me just write it there, theta plus I sine n theta. That means the n at this top here, we brought it down to this place. That means this down, I can easily bring it up back, just to reverse the case. So in this case now, I can now say that the nth power of this, since this one is just the first degree power, this is the first power here, so I can now say the nth power, z plus 1 over z raised to power n. The nth power of this will be 2 to the cos theta raised to power what? N. So this is what we want to derive in terms of cos. Probably you want to find the power of cos in the Morph's using the Morph's theorem. This is what you want to derive, the nth power for cos. Okay, so we'll be using this particular one. This is for cos here. Suppose you want to derive for sine. In terms of sine, you have to do the minus of this. Instead of writing plus, we do the minus. So let's quickly derive the one for sine, so we can use both formula to actually get to where we are going to answer the real question. Okay, to answer the real question. So what we want to do is, we want to do the negative. So z minus, still the same process, z minus z to power n. Okay, so I will still say that this is equals to r raised to power n, then cos theta plus I sine theta, I sine, so say r n cos n theta plus I sine n theta, okay, minus, see we are doing minus now, r raised to power minus n into the bracket of cos n theta minus I sine n theta. So still the same procedure we used for cos. We will say that this is the same as writing z to the n minus 1 over z to the power n is equal to writing r to the n. Okay, if we are to open the bracket, I will have cos n theta plus I. No, let me just clear up this space, please. So again, let's r be equals to 1, then I will have z is to power n minus 1 over z is to power n, okay, is equal to this. Since this one is now 1, the whole of this will be 1, so this is out, this is also out. So what I'll do is open the bracket, then I'll have this cos n theta plus I sine n theta. Okay, opening the bracket, I have minus cos n theta plus I sine n theta. Okay, which shows that this cancels this. So in terms of cos, I'll be having z to the power of n minus 1 over z raised to the power n. Okay, will be, if I add this one and this one together, so I'll be having 2 I sine n theta. So now bringing it also together the way we did for cos, what we'll do is that when n is 1, when we're dealing with the first degree, when n is 1, we would have z minus 1 over z, okay, is equals to 2I sine theta. Okay, and therefore the nth power for sine, just the way we derived for cos, would now be the nth power let me quickly clear this place so I can have a clear sheet. So the nth power also, for in terms of sine, the nth power now will now be z minus 1 over z power of n is equals to 2 I sine theta raised to power what? Raised to power n. So this is what we are going to be using to solve this question solely in the next video. So in this video, I just here to prove what we want to use. That's why this video, you need to watch it in series so you can actually understand what we are really doing here. So in the next video, we'll be showing how this is actually important to expanding cos raised to power 3 theta and sin raised to power 3 theta.